Hey everyone, let's go ahead and get started with a brand new lesson on Chat My PDF. This is going to be RAG with LangChain, Ollama and FAISS Vector Store, and this is going to be here a private RAG. If you are a privacy concerned person and you have a data which is a private data, then you need a system setup something like this where you have to host your application on a private server, and for the private server you have to have some LLM which can be hosted privately. So here I'll be using Llama, and we'll be using here Ollama as well. So the Llama 3.2 will be hosted on the Ollama, and then we will be using here Facebook AI similarity search vector store to store our data. Moreover, this whole lesson is divided into two parts: document ingestion part, where we will be ingesting our PDF document into a vector store database, and in the next part I'll be showing you how you can write your RAG. So for the RAG, I'll be showing you, let me just scroll it down a little bit. So here you have a retrieval and generation. So after data ingestion, we will be retrieving the chunk, okay, relevant chunk, and we will be passing our question along with this chunk to our LLM. Llama 3.21 billion model, which is hosted on the Ollama, and then finally we will be producing here final response. Let me just explain you through the block diagram. So this is our document ingestion process, how we are going to work. We'll be having here a lot of the PDF document related to health supplements, and then we will be passing this document to our vector embedding techniques here, Ollama embedding. We'll be using here nomic embed text data, and then we'll be storing all these embedding to our FAISS vector database. Once it is stored, then we will be using here again Ollama embedding so that we can embed our question, and then through the cosine similarity we will be trying to find out the relevant we'll be trying to find out here the relevant chunks. Once we retrieve the relevant chunk, then we will be passing this question along with this chunk to our LLM so that this can produce the final output. Along with this, we'll be also using here a Langsmith so that through the Langsmith we can actually find out that how overall our RAG is working. So through the Langsmith you can understand that what is going behind the scene. It can tell you that how the chat Ollama is being used, which model was used, how many tokens were there, how much time it took to process. All those things you can see it here. And then what are the document which was retrieved from the vector store, and then finally what was the final output from the vector store. You get something like this. And then what was the final output produced by the chat Ollama, or you can say that your local through your local LLM. Along with this, I'll be also going through the nomic embed text, and thereafter I'll be showing you how you can install, how you can pull Llama 3.2, and then how you can install Ollama on your computer. Thereafter, we'll be also briefly going through the Facebook AI similarity search, and thereafter I'll be also showing you from where you can get the dataset. So RAG dataset will be taking from the Lakshmi Merit RAG dataset repository. So we have here gym supplements and health supplement, and thereafter I'll be showing you where you can get the code. So this whole code you can get from the Ollama chatbot. After this lesson I'll update, I'll push our code so you can get that from here. And thereafter I'll be going through obviously with the Langsmith, and then through the LangChain documentations as well as I code along here. All right, so this is going to be a line by line coding lesson. So it'll be like 1 to 2 hour of the coding lesson. So I'll be doing this line by line. As I do this line by line, I'll be taking you through the LangChain documentation as well so that you can properly learn this whole thing here. I hope that you are going to enjoy this. All right, so this is enough talking. Let's go ahead and get started with the coding. All right, let's go ahead and get started with the coding part of the Chat My PDF RAG with the LangChain, Ollama, and FAISS Vector Store. So we are going to use all of these libraries together to make sure that our RAG works. And moreover, overall focus would be here that you can build your own local LLM based RAG system here so that you can do RAG using your private data with your local LLM. So to host our local LLM, we will use here Ollama. we will be using Llama 3.2 model, which is the latest model, comes from the Facebook and the Meta. And we will be using here LangChain as well, so that this LangChain can coordinate with the Ollama and the Llama 3.2. We will be using here Facebook's vector store model. So this is Facebook similarity store vector store model actually. It is known as a FAISS here. So we will be using this particular thing to store our data. All right, let's go ahead and get started with our building block first of all, and make our flow chart or block diagram just to understand that how our chat my PDF is going to work here. So as discussed previously, we are going to first of all make our block diagram, and we will understand that how our chat my PDF is going to work here. So it is two-step process. In the first step process, we are going to do here document ingestion. So it is like this. Let me just make it a little bit larger here. So it says that here document ingestion. So it is like storing your document in the database. Thereafter there is another step. In that step we do here retrieval. All right. And after retrieving, you can say that there is a third step actually. So in third step we say that generation. All right. So in the generation part, this and this, you can say that in middle, the somewhere there is LLM involved in between this and what we had seen previously, that FAISS database, that is here, right? So this comes from the Facebook. So what happens here? You have a lot of PDF data. You can see that here lots of PDF data, lots of PDF data here. So this PDF data get ingested into the files. Basically you can say that this get ingested here, and then it comes here, and through this files then the retrieval happens. Then through this retrieval, this LLM takes that, and also LLM takes the question as well here, and that question also goes to here at this your vector store database. And thereafter you have here a context, and at this LLM, now you have the context. That context is coming from here, and then you have here a question that is coming from the user directly, and then based on that it can do the generation. So this is overall process how this whole thing is going to work. Whatever we are currently seeing here, chat my PDF, this is how it is going to work here. On a broader level, you can say that on high level, this is what we are going to design. Now I'm going to show you separately how this document ingestion works, and thereafter I'll be showing you how this retrieval and generation process works here. All right, so I'm just going to scroll it a little bit down here. Let's say you have here your document. All right, so all the documents are here, and this document which you have here, I'm saying that these are my PDFs document here. All the PDF documents are here. And thereafter we need to read these PDF documents so that we can convert this into a text data. So I'm going to convert this into a text data. This become text data. So the overall process, what you see here, this whole process is known as the text extraction data, or you can say that here extract text. All right, so we extract our text data here. Which library we are going to use here? We are going to use here PyMuPDF library. So this is Python library. We will be using this library to extract our data. All right, let's go ahead and put it here in the middle. All right. Thereafter, what we are going to use here. So once you have your document and your text data, thereafter we need to split our text data into a smaller chunks. Why that part is needed? Let me just explain that here. Suppose that you have a PDF document, and that PDF document is very huge document, right? So let's say it is very huge document. Maybe it would be right to do something like this. And let's say it is 100-page document. So the 100-page document means the context size is going to be very large. But large language models have a smaller context. So let's say if your language model context size is this much only. All right. So if LLM context is only this much, I'm saying here, let's say your LLM context, then obviously you cannot, feed this whole data together. All right. So the context size is only this much. So what you have to do here, you have to actually you have to divide this whole data into a smaller chunk basically, right? So what you can do, you can divide this into a smaller chunks here. Moreover, we also do here like, the overlapping. So basically we divide it into a smaller chunk so that overlap can happen. Why we need overlap? Because let's say if you have your chunk which is like this much only, and you have some paragraph and the context is overlapping there, in that case you have to have there overlapping between the chunks. So basically if I say that the overlapping between the chunks, then what does that mean? So that means that let's say you have something, okay, one second. Let's say you have something like this. And if we do it something like this, then it is going to create a problem. Maybe I can just delete this whole thing. I can keep this one, right? So if I keep it something like this, then in that case, what will happen there? There is no overlapping between our chunks. And if there is no overlapping, then sometimes what can happen here for a particular text data where you have a running context at this particular split, then in that case, what will happen? Some context will be in the previous chunk and some context will be in current chunk. Just to avoid that particular thing, what we do here, we actually take our we actually create their overlap, so that if there is any context which is overlapping between the multiple chunks, we can actually get that context completely either in this chunk or into the next chunk. So remember this part in the coding, we will be needing this part when we will be doing our data split. At that time we have to use this particular thing there. So that is what I'm going to use here. So I say that this is going to be my text chunks here. All right, so this text chunk is going to be a little bit larger here. So I make it something like this. And in this text chunk, you have a lot of chunks here, smaller chunks, something like this. So those chunks are going to be smaller chunks so that our LLM context can get adjusted in that. All right, so I make it like this. So many smaller chunks, you can say that, right? Like this, I'm gonna make this. So these are the smaller chunks data. Once you have all these together, thereafter what we are going to do, let me just make it a little bit smaller. And also our text size, I'm going to make it medium. Okay, perfect. So let me just make it a little bit more smaller. Now we have our data here. All right, thereafter, once you have your chunk, then you have to store it into your database. All right, so here the database, what we are talking about, here we are talking about the FAISS, that is the FAISS database. So in the FAISS database, we need to store all the chunks there. All right, so what we do here, we are going to create here we are going to store it into a database here, right? So I'm going to create their cylinder actually. So like this, and this cylinder is going to be my database, or I can say that here database, maybe that would be right to put it here. All right, let's remove this one and put it here. So this is our vector database. I'm gonna give here name, and for this I'm going to give here a name as the vector database. All right, and which database it is? It is actually FAISS FAISS vector database. All right, so all these data are going to be stored here in the FAISS vector store. So what I do here, I take it from here and put it here, and in between which process it is going to use here, And process it is going to use here, let's say I'm going to use here Ollama embedding. All right, so we'll be using here Ollama embedding. And the model, which model we are going to use here? We are going to use here nomic text method. So you can search that method here actually. Nomic text embedding. So you have this nomic text embedding which outperforms OpenAI ADA 002 text embedding. So this particular embedding we will be using here, and we will be using through the Ollama here. So you can say that this is, the embedding which we are going to use here. So I'm just going to put that name so that you can remember that. So this is particular embedding type which we are going to use to embed our data into a vector store. So this whole process is known as document ingestion. So I'm just going to put this everything whatever you see here as the document ingestion process, right? So I'm going to put here the heading. So what heading I put here? Document ingestion. All right, so I'm just going to make it a little bit larger and then I put it here. All right, so this whole process, what you see here, this is the document ingestion. So in our previous, example, what we had seen here, there is the multiple, there is actually two important process here, document ingestion and retrieval and generation. Actually, although there are so many, in between process, but I'm just saying that these are the two main process, document ingestion and then retrieval and the generation process. All right, so what I do here, I'm just gonna put it here, and thereafter let's go ahead and try to understand that how our retrieval LLM and then this whole generation process works here. All right, so this is independent to the user question. Do remember that here user question doesn't come into the picture. Now we are going to design here for the retrieval process. So for the retrieval process, first of all, there would be a user and user question here. So what I write here, it is going to be here a question. And for this, I'm going to put a medium, text size. So this is user question here. I'm going to put here a user so that I can say that this is user who is asking here a question. All right, so you can say that this is user who is asking this question. Once user asks the question, what happens here? We have to use here same kind of the embedding so that the similarity score can be calculated between the question and whatever the document we have embedded here in our vector database. All right, so what I do here, I'm going to just copy this and this, these two things from there, and then I come and paste it here so that I can say that, okay, this is the same embedding process. All right, and the same, same the model and same embedding process is going to happen with our question so that it can retrieve relevant, so that it can retrieve here, the relevant document chunk from our vector database. So, so after this embedding is calculated here, so you can say that question embedding. All right, so the question embedding is calculated here. Now we have to apply here the cosine similarity to this database. So this whole thing I'm just copying from there to here. Just do remember this is the same thing what we have here. All right, so this is the same thing here. So I just copy this whole thing and just put it here a little bit, down, maybe here. And then I say that, okay, this is coming here. And overall things what you see here, I'm going to say here that I'm calculating it through the cosine similarity here. All right, so this is the method which we use to find out the relevant chunk of the data here. So you see here, out of all the PDF data which we have here, there are so many chunks, hundreds or thousands of the chunk there. Out of those chunk, whatever the question I'll be asking here, those relevant chunk will be returned by our vector store. Which vector store database we are using here? We are using here FAISS Vector Store database. Let me just quickly show you about this database here. So this is Facebook library. This library is very efficient library. Its name is here, efficient similarity search and clustering of dense vector. So this is very powerful library. This was developed by the Facebook. So that is what currently I'm using here. All right, so the FAISS vector database we'll be using here. And through the cosine similarity, relevant chunk of the data will be retrieved here. So I'm just gonna copy here a few things so that I can paste it here. All right, so those, the chunks are, just retrieved here. Some chunks are retrieved here out of this database. All right, so you can say that something like this. Once you have all the chunks here, then you can apply your LLM on this chunk and then on the question. All right, so what I do here, I put my LLM here. So what I write here, I'm just going to take here brain, and I say that this is my LLM. All right, which LLM currently we have here? We have here Llama 3.2 1 billion model. All right, so this is our currently, the LLM which we are using here. So that particular LLM we are going to use here. All right, so all of these things what you have here, this comes here. First of all, I'm just going to put this everything here inside this box so that this can look, pretty. All right, so this all these context whatever we are currently seeing here, all those will be going here to the LLM, and then it will be generating the final output. All right, so there the LLM, and this LLM also gets here the question from here. So you can say that this question comes from there to here as well. All right, so we are just going to put it here. Once you have your questions and relevant chunk here, then this generates final response here. So you can say that this is generating a final response. It's not like that. It should be from here to here. There you have your final response. All right, so this is your final answer. Now you can put this everything whatever we have here inside a box, and then you can say that okay, now you have got your answer here. All right, so this whole thing what you see here, this is the retrieval and generation process. All right, so I say here that this is going to be your retrieval and generation. All right, I'm gonna set here, large, and then I put it here. Perfect. Now what do you see here? If you just zoom out a little bit, it might not be visible to you here everything, but here two things you see here. One is the document ingestion, another one you have here retrieval and the generation process. All right, perfect. So now you have your retrieval and document ingestion here. So this is overall process, and here you have your retrieval and generation. So the first of all, we will be focusing on the document ingestion process. So what I'm going to do here, I'm going to take a screenshot of this, and then I'll be pasting this into my, you know, into my notebook here. So what I do here in markdown, and then I just paste it here so that I can refer this whenever I want. I can refer that this is my document ingestion here. All right, so this is the overall process which we are going to follow here. Now you have your PDF here, right? So first of all, now before we get started with the coding part, we have to also get our PDF here. All right, so for the PDF, I have already provided here the link. So through this link, you can get the PDF. All right, so I'm just going to copy this link from here, and then I'll be downloading all the PDF here. All right, so you can come here and paste it here. It is available at my GitHub repository. So you can search there on my GitHub repository as RAG dataset. It is already there. In this RAG dataset, you will be seeing their gym supplements and the health supplements. So these are the PDFs. We have 3 PDF in health supplements, and we have here 2 PDF in our gym supplements. So we are going to use all these PDFs together, all those 5 PDFs together, and then we will be asking there a question. A relevant, the answer will be returned through our PDF data. And if our LLM don't find any relevant context through our database, it will say that I do not know because that thing is not present in provided context. All right, so this is overall things. That is how we are going to work here. All right, so this is the data. You can simply download it here. So you can download here, download zip. Once this zip is downloaded, you can just, you can just extract this whole zip. So I just extract this whole zip data, and thereafter I have all these here. So what you need to do here, you just need to copy these two folders, gym supplements and health supplements. These two folders you need to put here in your in your the folder here. So here is the folder. We have currently our chat my PDF folder. So there I'm going to make one data, so that is going to be RAG dataset. All right, a folder here actually I'm making. Inside that folder I have pasted these two. So you have here RAG dataset. Inside that you have here gym supplements or health supplement. Other than that, you could have directly just you could have just named this, renamed this actually RAG dataset. Thereafter, you could have put it here directly, something like this, just the drag and drop. Whatever you prefer, you can do that. Basically, you here want some PDF data. Currently, we are having here the gym supplements and health supplements. So these are the two type of, the two folder which contains 5 different PDF. We will be reading all those PDFs together. We will be extracting those PDF through PyMu PDF, and thereafter we'll be converting those into the text, and then we will be doing here chunking as well. So the recursive text splitting we will be using here to generate multiple chunks of our PDF data, and then we will be using Ollama embedding with the nomic embed text model to embed our chunks so that we can store this into the FAISS vector database or vector store. All right, I hope that this overall process is clear to you. By now, you must be, comfortable to understand this overall process properly. Okay, if you have any doubt, you can comment below. You can ask the question. You can, you can ask your doubt in the comment section. All right, let's go ahead and get started here with the coding. So first of all, you have to install all these libraries here. So I have provided here, and the code for this RAG, my chat with my PDF is already provided. So you can also get this code at my GitHub repository. You come here at the Lakshmi Merit, and thereafter you need to search here Ollama chat, right? So you can search here Ollama chatbot. So here you have Ollama chatbot. All right. So there I'll upload that. You can find out that particular, the RAG code here. So whatever the code currently I am doing, you can find out from the Ollama chatbot repository. All right, let's come back here. So all these necessary libraries I need to install. So I have already installed this, but again, I'm just going to show you how you can install this. Make sure that you are activated. You have activated your environment. So I'm using here ML environment, and then I'm just going to paste it everything. So whatever I had copied from here, this whole thing I'm just going to paste here. Now you will be seeing here all these will get installed, although I have already installed everything. So whatever was the older version, so those got updated as well. So everything here got installed here. All right, so this whole thing you have to install. Other than that, one more thing here I wanted to show you, that you have to make sure that you write here os.env environment kmp duplicate lib ok equal to the true. Sometimes what happen, if you are working with the LLM where you have installed your FAISS library, along with that if you have also installed the Chroma DB, sometimes that create a problem. Just to avoid those problem, you need to set this. Otherwise, while chunking and embedding your data and while storing it into the database in the vector store, it will throw the error, your kernel will get died. So just to avoid that particular issue, I have added this thing here. Other than this here, I have also filtered out all the warnings, although in the production or at least in the development you don't need to do, but as of now it is fine. I just wanted to, avoid all these, the nasty, the warnings which unnecessarily, creates confusion. Just to avoid that particular things, I have done that. So here is the load environment. So this load environment is very critical here. So for the load environment, you have to have here some APIs. So as you know here that we are using Ollama. So Ollama doesn't need any API here. All right, we are not using any, OpenAI API or anything else. Now the question is here why we need then this. So we need this to track our development here. All right, so we are going to use here LangSmith. So for the LangSmith, we have to use some kind of the API so that we can track our development. Do remember LangSmith is free of cost. It is not going to charge anything. Now the question is here, why do we need then LangSmith? Whenever we will be working with our LLM, so whenever the user question comes here, then this is going to find out some relevant chunk of the data through the cosine similarity. Just to understand that and just to know that what are those, the context, what are those data which have been retrieved from our vector database, we have to use some kind of the tool here. And that tool is LangSmith. So that tool we are going to use here. So here is the LangSmith. You need to just, log into the LangSmith. The link is here, smith.langchain.com. You need to create an account here. It's free of cost, completely free of cost. This is tool provided by the LangChain. Then once you are signed up with the LangSmith, then you have to come here in the setting. In this setting, you will be getting here API key. So you need to create here API key. All right. I say here that chat my PDF. So this is my API key. Thereafter, personal access token, you can just simply say here, create my API, and thereafter you can just simply copy this from there. All right, let's come back here. Here we have to create our, the environment file. So .env file, I create here .env, and thereafter here I have to say that lang smith API key, and here I'm going to store my API key, right? All right, so instead of the LangSmith, it is going to be actually the LangChain. All right, so you have here LangChain API key. So this was our key here, and I'm just going to put it here inside the double quote, although that part is not needed in any way. I'm just going to put it here. Thereafter, you need to come back here. So I say that I have saved this. Other than this, you need to come here in the API, the documents here. You can just, click on there. Thereafter, it will show you what are the things which you have to, I mean, how you need to do that setup. Seems like that setup is not available here. Maybe through the example. Just a second. Okay, so it's not there. What we have to do here, you need to come here in the usage. No, it's not here. Wait a second. Wait a second. It's better if we search here LangSmith tracing. So I say here LangSmith tracing. With this, I can say that, just click on here, how to trace. Right, I click it there. Thereafter, it says that, okay, so these are the things which you have to do. LangChain API key, that setup we have already done. I'm just trying to figure out where are those names actually, right? Wait a second. All right, so it says that we have to say that this environment variable need to be the true there, and then this key is already there, and thereafter we have to also set there the project. So these things we have to do. Let's go ahead and do those setups directly instead of trying to find out those things here. All right, so what are those names which you have to do here? So the first of all, you have to again say here LangChain, and thereafter project. So it is going to say that what is the project name which you are going to do here. So I say that chat my PDF, that is going to be my project name. Thereafter LangChain endpoint. So I can say that here LangChain endpoint. So this is going to be the LangChain endpoint, http api.langchain.com v2, and then okay, only this much, https api dot api.smith.langchain.com. All right. Thereafter, I'm going to say here LangChain tracing equal to the true. All right. So I say here LangChain tracing v2 is equal to the true. All right. Perfect. So I have all these, the environment variable setup. So once these environment variable setup is done, you can just simply close it here. Thereafter, if you run this load env, so this env file will get automatically loaded here. Do remember this have to be into the same directory, otherwise it will not load. Thereafter, I'm just going to simply run it. Let me just disable my, the completion from here. All right. So now you have here your environment. If you want to check your environment has loaded correctly, so you can just say that environment, and you can provide, the name of that variable which you want to see here. It says that, chat my PDF. So this is what we had provided, and seems like it is working perfectly here. All right, let's come back to our figure here. So our architecture. So in architecture, we have seen here, there is the document, and we have already installed all the necessary libraries. And we have also installed, we have also done the setup of the Langsmith tracing so that we can see what is happening. All right, so once all these things are done, now we can get started with the loading our document. All right, so we are going to load our document using PyMu PDF. So PyMu PDF loader is available in the LangChain. So you come here and search here LangChain PyMu PDF. All right. So in the PyMu PDF LangChain, here you have that. All right. Make sure that you are with the latest version here. So you need to click on here PyMu PDF loader. With this, you can see here the API details, complete API details. Otherwise, you can see the use cases here. Just scroll it down, and this is the whole thing what you see here. That is how it will be actually used here. So through the LangChain community dot document loader, we will be importing PyMu PDF loader, and then we will be passing our PDF here so that it can finally load it. So I'm just going to copy it from here, and then I'll be pasting that here. All right. So you see here PyMu PDF loader, and thereafter I have to provide here a PDF document. So my PDF documents are here. So I'm just going to take here the first PDF, and then I copy the relative part from there, and then I just paste it here. Thereafter, I know that this is my current directory. So RAG dataset, I have to make it /, otherwise it will throw the error. And this is my PDF. All right. Thereafter, after this loader is equal to the PyMy PDF, then you have to call here load document. So you can say that loader dot load. So with this, it is going to load it here in the document. All right. So you can just simply run it here. After running this, what you will see here, you will see a lot of document here. All right. So these are the document classes, document object, you can say that. And each of these document have a lot of information which you can see. Initial information, you might see that a lot of initial informations, whatever information you are currently seeing here, all those informations are duplicate informations currently. All right, so all these initial informations are duplicate. The reason is here that these informations are actually the metadata. All right, so these informations are metadata. That is why these are a duplicate information right now. All right, so let's go ahead and see the first document here. So you have your doc is equal to like this. Here you have your document 0. That is the doc 0. Thereafter, I come here and search my doc. All right. So here you have your document. In this document, you can see your metadata. So these are your metadata. So these are the information about your PDF data. And if you search here page content, then you can see that this is the page content. All right. You can just do here a print and thereafter do something like this. Now you will be seeing here, this is the page content here. All right. So this is the first page content here. All right, for your PDF. So which one is this? Analysis of the actual fitness supplement PDF. So this one. All right. So in this, if you compare whatever you see here, if you compare this information with this information, what you are seeing here, you can match that those information, right? So here it has emails and authors, etc. So those emails you can find out somewhere here. Let me just see it here. Yeah. So here is the email. All right. So those emails you can find out some initial information you can also find out here. Some initial information like here there is the introduction, supplementary drinks or fitness supplementary, etc., etc. So you will see here that so these text data, whatever you are currently seeing here, this text data has been actually extracted properly. There is no problem with that here, right? Perfect. All right, let's come back here again. So let me just explain you here. So we actually imported PyMu PDF loader, and thereafter we had loaded our data, and then we got our final output here, right? So supplementary drink, etc., etc. So all these data have been exported here successfully. Now you need to come here and then you need to understand that the architecture which we have defined here, is it following that or not? So in the architecture, we have a documents here. All right. So all the PDF here. Currently, we are reading only one PDF. So that is the problem. We have to read all the PDF which is inside this RAG dataset document. So to read all the PDF, we have to first find out all the PDF, whatever we have here through the OS, and thereafter through the OS and the walk directory or list directory, and thereafter we have to extract all the text data through this PDF. All right, so this is what we are going to do here. So the first of all, what I do here, I'm just going to copy and paste it here, and then I'm just going to comment that, and thereafter I am going to say here, first of all here I'm just going to say this is going to be the document loader part. All right, now I'm going to import OS so that I can list out all the PDF document which we have here. Thereafter, I say here OS dot walk, and then inside this walk you have your RAG dataset. If you do like this and if you walk here, so you will be getting all the PDF document here. All right, so this walk is going to give you the root directory and all the directory and the files inside that. So I say here root and directory where the files are, and then files in each directory. So it is going to be something like this. If you print this, something like this, root dirs and the files, then you will see all of these things. You see here, this is root directory. In this root directory you have this, and thereafter there is another root directory that is going to be, it's actually the nested directory. So in that you have now your two files, this one and this one, and then there is the third one, that is the health supplement. You have there three files. All right, now in the files, this one which you have here, so we are going to iterate over the files. So I say here for file in files, and thereafter I have to check here if file dot ends with dot pdf. All right, because we are reading only PDF file. Tomorrow if some other file comes, then that file will not be actually taken. So I can just make sure that if file ends with the dot pdf, like this, only then read that file. So what I do here, I'm just going to say that here it is going to be the PDFs is equal to empty list here, and thereafter I'm just going to, you know, read all these PDF files here. So I say here PDFs dot append, and then I'm just going to do here like this. That's all I have to do here. And then this print which I have, I don't need that. Now I can just simply check all the PDF path here. How many PDF documents are there? There are total 5, and all those PDF path I can now see here. All right. So once you have all the PDF document path here, now I can just simply, call my, I mean, PyMu PDF loader to load all the data, right? All right. So the name we already have here. One thing we also want here, the whole directory. So currently we do not know that where these files, from where these files are coming. So I think that problem I made here. So what you have to do here, you have to write here os.path, thereafter join, and in this you have to join it through the root directory. Otherwise it will provide it will give you a problematic output. Now I can find out that which file is coming from where. All right. So all the PDFs are here. Let's go ahead and read it like we had done previously using the documents. So I'm going to say here docs is equal to something like this, an empty list, and then for PDF in PDFs. So now for all those PDFs, I'm going to use this previous code like this, whatever I have here. But only the difference here, this path which I'm currently giving, that path is already coming into this PDF, because I know that each of these items, whatever I see here, each of these items are now a path here. So this path come here, and thereafter there is loader, and then this documents, whatever I have here, this is actually the pages. All right, so these are the pages for each the PDF, and then I'm just going to extend my document with these pages here. All right. So with this, all the PDF document, whatever I have here, all those are going to come inside this document. Now you see that I'm getting here very, long list of the document. And in this long list of the document, you can see all the sources here. So the different sources are there. That means all the files are getting, read here. So we have, you know, we have read all the files there. So how many pages are there? You can check that with the length of this document. We have total 64 pages of the document here. All right, so this is the total data here. All right, let's go back to our architecture here. So now we have extracted our text data. So we have reached till this stage. Now we need to do here text chunking. So which type of the text chunking we are going to use here? We are going to use here recursive text splitter. All right, LangChain. So this is recursive text splitter. We are going to use it through the LangChain. All right, so this is code which we are going to copy from here. If you install the LangChain, then it will automatically install LangChain text splitter. Otherwise, you can install it separately as well. So this thing, I'm just going to copy it from here, and thereafter, I'm just going to come back here, and then I'm going to provide here, a markdown, and this one I'm going to say that here document chunking. All right, so in the document chunking, I'll be using here recursive character text splitter. This is from the LangChain, and input parameters, you can see here that it has here chunk size, chunk overlap, length functions, and so many other things. So this is aligned with our instruction which we had discussed previously. If you remember, we have a very large data set, and there is a limited LLM context window. And as per the availability of the context window, we have to make sure that our chunking is done accordingly. As you know that we are using here nomic embed text data. So the context window for this one is around 4K. So one more thing you can see here, in fact it is saying that seems like the context seems like 8K for this one. So for 8K is the total context window, but that much context window we don't need. So that is the maximum context window, maximum context window for nomic embed text model. We'll be using around 500 the tokens for our context window. So that is going to be the maximum length, and then there is going to be the overlap. So whatever you see here between these two blocks, so this is the overlap, and this overlap is measured into the character. All right, so that part we are going to cover here. So the first of all, I write here text. This is not a markdown, this need to be the code actually. So I write here text underscore splitter is equal to recursive character text splitter. Inside this, I'm gonna say here chunk underscore size is equal to 1000. All right. So I'm going to use here 1000 character as my chunk size. And how many characters I'm going to use here for overlap? That part I'm going to provide here. So I say here chunk overlap is equal to 100. All right. Thereafter, I write here chunks is equal to text splitter dot split document, and then I have my documents here, all the documents. All right, so this is what it is going to do. It's going to split my document into so many chunks. If you compare the length of all the documents with the length of the chunks, then you will understand this. So the total document we have here 64 pages, but the final output we have here, the number of chunks total 321, that you can understand here. So you had a single text data, and that text data got converted here into the multiple chunks. So that is what we can see here, that this almost 60 got converted into 300. That means seems like we are actually getting around 5 chunks out of each document, or out of each page. So we are getting around 5 chunk. So now what we see here, that so the chunk whatever I can see here, that out of one page there is 5 chunk. That means the 20% of the document page is coming as a single chunk data. All right, so the document chunking is done here. If you print this chunk, you will see here as the document itself here. You will not see any difference here. Only the difference which you can see, that difference will come here into the page content part, right? Other things are going to be the same. So whatever you see here, that is page content, that is going to be, a different, that you can compare with the document. So you have, let's say, the first document. In this first document, you have here page content. All right, so this is whole page content. Let's go ahead and print this. So you will be seeing here the first page content. All right, and if you come here and print your chunks, so the chunk dot 0 and then the page content, then you can see the difference here. So this is the output for the chunk, a very small output which you can see here. And here you have a very large output for your document. All right, you can also compare here the length as well. So the total number of characters around 4000 are there, and if you compare that here, so you will be getting around 1000 characters. All right, now I'm sure it must be clear to you that how this chunking is being done, why we need to do the chunking, because this is very important part. All right, perfect. Now let's go ahead and see how many tokens are there. I can see that these are the total number of the characters, but we do not know that how many tokens are there. So if you want to know the total number of the tokens, you can use here tick token from the OpenAI. So I'm going to import here this tick token, and thereafter I can say here encoding is equal to tick token dot encoding for model. Which model we are going to use here? Let's say GPT-4o mini. So for GPT-4o mini, we want to know that how many tokens are there. So that thing we can test here itself. So I say here encoding dot encode, and this thing what I see here, this thing I'm going to copy and paste it here. It says that total 969 tokens are there in the page content. Similarly, I copy and paste it here. Then I can put it here as chunks. And in this chunk, it says that there is total 300 token. So the 300 token is well, well smaller than the total context size of our model. So this nomic embed have around 8,000 context size, 8K context window. So that is, a lot larger than what currently we are having here in the LLM context. So this LLM context is large here, and whatever you have here, these, chunking, these chunkings are small. That is very good actually. All right. So LLM context need to be large compared to the chunking size, and which is perfectly aligning with our, the requirement in our case here. All right, now let's come back to our architecture. So this chunking part is done here. Now we need to do embedding here. So with the embedding, what we can use here, we can use the Ollama embedding and nomic embed text. But before we use Ollama embedding, we have to install Ollama here. All right, so you come here at the Ollama. All right, you just search Ollama. Thereafter, you need to come here at the download. You have to download the Ollama for the relevant operating system. So I have here Windows. I just download it from here. All right, it is going to download. Once it downloads, then you have to install it here. After the installation, you will be seeing here in the taskbar, Ollama will be running here. So once you get the Ollama running, then your task is done. Always do remember that Ollama is not going to open here any GUI, something like that. Once it is installed, thereafter you will be seeing that Ollama is running here. Once Ollama has started running, you need to come here inside this models. Inside this models, you have to get here Llama 3.2. In Llama 3.2, we are going to use a model with the 1 billion parameter. This model is quite fast model. That is why I'm going to use this one. And my computer architecture and computer, the system here, if you want to know that what's the system configuration. So currently I'm using here 32 GB of RAM, and I'm using 6 GB of GPU RAM. So general CPU RAM is 32 GB and GPU RAM is here just a 6 GB. All right, so I have this 1 billion. I have selected this 1 billion. Thereafter, you need to copy it from here. You need to open your terminal. Once you open your terminal, you need to run it here. Ollama run Llama 3.2 1 billion parameter. It is going to download it, and then it is going to run here. You can ask the question here as well. You have to make sure that this is downloaded in your computer, otherwise it will not work. So once you have that part running, you can also use here pull as well. You don't need to use their run. So with this pull, if it is not present in your PC, it will just download and put it there. Thereafter, you have to also download this nomic embed text as well. So here it has Ollama pull nomic embed text. You need to copy that there, and thereafter you need to paste it here. Ollama pull nomic embed text. You need to run it here. So if it is not present in your PC, it's going to download. All right. So these two models you have to download, Llama 3.2 or any model, whatever the LLM model you prefer, you can download that simply without any issue. And then whatever the embedding models the choose, those embedding models you can also download. So currently we have here nomic embed text. That's our embedding model. Let's say if I select here embedding, and I select here embedding, all these models, whatever you see here, all those models are embedding model. All right, so there are so many embedding models here. You just don't need to stick with this model. You can just search that whatever embedding model you prefer, that embedding model you can use. Now I hope that you have installed Ollama and you have also, pulled out Nomic embed text and the Llama 3.2 or any other LLM model, whatever you prefer. Once all these things are done, now we are ready to do our document vector embedding. Let's go ahead and do that document vector embedding. So I'm going to write here document vector embedding. So for the document vector embedding, we have to use here Ollama embeddings. We have to also use our FAISS vector, and we have to also use here, the LangChain community vector store. So all of these things we are going to use here together. All right. So first of all, we import here Ollama embedding from the LangChain Ollama. So I write here from LangChain Ollama. All right. Thereafter, I write here import Ollama embedding. Seems like this is markdown. I have to make it Python. Okay. So from LangChain Ollama import Ollama embeddings. It should be embeddings here. All right. Perfect. Let's go ahead and see what are the library which we have installed previously. So these were the libraries which we had installed previously. You need to make sure that you have all of these. Like we install LangChain community, we install here FAISS CPU, this is Facebook AI similarity search. We have installed LangChain Hugging Face, PyMu PDF, Tick token, LangChain Ollama, and Python.env. All right. Perfect. So all these necessary libraries you have to have in your computer. Let's go ahead and import our FAISS here. So I write here import FAISS. Thereafter from LangChain community dot vector stores import FAISS. Thereafter again from the LangChain underscore community dot doc store dot in memory import in memory doc store. So basically this one will be used to store our the vectors in RAM, and this is the FAISS from the LangChain, and this is original FAISS library provided by the Facebook. All right, so all the necessary imports are done here. Thereafter you need to simply create the embeddings here. All right, so you need to get the embedding object. So we can get that embedding object directly like this. Embeddings is equal to Ollama embedding, and we are going to use here model which we had discussed previously. So this is our model, Nomic embed text model. That model you can see here as well. Let me just search that here. Nomic embed text model. So this is our model. This particular model we are going to use here. Simply you can copy this from here. All right, that name I copied from there and then I paste it here. Nomic embed text. All right. Thereafter I need to provide here the base URL for my Ollama. So where is my Ollama running currently? My Ollama is running here in local system. All right. So I have Ollama here. This is running. So on local system, at which port it runs? It runs here at http forward slash localhost and thereafter 11434. All right, so this is port for my Ollama. You can just come here and paste it here somewhere. Let me just get something. Maybe here I can paste it here. You can see it here that Ollama is running. So this is Ollama address. That is where our Ollama is currently running. So we have got here the embeddings through the Ollama embedding. If you want to know more about this, you can just simply come here and then you can just search here Ollama embeddings LangChain. Like this, you will be redirected to the Python LangChain. So here you will see. All right, so embedding, you can also provide other models like Llama 3 model or any other model, whatever the model you want to use here. Thereafter you can just simply call your embedding along with the vector store. All right, so that you can get the embedding. If you want to call your embeddings directly. You can also call your embedding directly using embeddings.embed text or embed query, actually, something like this. Let's go ahead and see this. So I just copy it from there and then I'm gonna paste it here. This is single vector. Here is the embed query. Okay, this is some text data, let's say. Now this is going to create here embedding. All right, that embedding is going to be placed here inside this single vector. You can check the length of this single vector. So if you check the length, you will see here 768. So this is your vector size. For each of these query, you will be getting 768 vectors there. All right, I mean 768 items in each vector. All right. So we have created our embedding using Ollama embedding. Let's go ahead and create our FAISS database here. All right, first of all, I'm going to get the index. So through the index, we will know that what is the size of the vector. All right. So what I can do here, I can say that here is index is equal to FAISS dot index. All right, index flat L2. So basically we are going to create here index with the L2 norm. All right, so the flat L2, you can put your cursor here. All right, then you can see here the detail index flat L2. All right, so this is overall, the code behind the scene. All right, so we have here FAISS index flat L2. Thereafter, we need to provide the length of our single vector here. So currently this is our length 768. So our index is created here. You can just simply print your index. You will see a hash value is printed here. You can also get here the total number of the items currently inside the index. So you will see here that there is 0 item because we have not, we have not stored any item as of now. You can also check here the dimension as well. So it says that the index dimension 768. This is exactly what we had seen previously. All right, so we have got our FAISS index. Now it is time to get our FAISS vector store address. So to get the FAISS vector store address, what we need to do here, we have to call our FAISS from the LangChain. So this one we have to call, and we have to also use in-memory doc store as well. So what I write here, vector store is equal to FAISS, and inside this FAISS, you will see here you have to provide your embedding function, that is Ollama embedding function. Thereafter, you have to also provide their index. So the index which we had created previously, and then you have to also provide their doc store where you are going to store your document. We are going to store our document in memory itself. That is why we had imported in memory doc store. All right, so all these things we are going to provide here. So the first of all, I provide here embedding function. So that is going to be the embedding. So this embedding we got from the Ollama nomic embed text. Thereafter we have here index is equal to the index. Thereafter we have here doc store. Doc store is going to be the in-memory doc store. Then finally, I'm going to provide here index to doc store ID, and this is going to be index to doc store ID. This is going to be here an empty dictionary as of now, but once we add our document in the vector store, then we will be having all the document IDs inside this particular key in our vector store. All right, let's go ahead and run this. Now we have got our vector store. Let's go ahead and print this and see. So this is hash value in our vector store. We will not be able to see anything else other than this hash value. That is perfectly fine, no issue. Let's go ahead and store our document here. So we have our document here. This is doc, and this doc is here. What you see here, this is a single page document. All right, for from all PDF, these are the individual pages. One more thing, we know that here we have already chunked this document in the chunks. So you can say here this is chunks, and if you check the length of these chunks, this would be around 321. Right, let's go ahead and come back to our architecture here. So this was our architecture. So we get the document here, and thereafter, I mean, you can say that we get our whole doc here. Basically, you can say that this is our whole document here. So at this location we get, let me just delete that, actually that doesn't look good. So our whole document is coming here, and then finally final chunk we get, and that final chunk goes inside our FAISS vector database. All right, so this chunk is going to be added in our vector store. Let's go ahead and add that. So what I do here, IDs. So why this IDs? Once we add our data inside this vector store, it is going to return ID, relevant ID for each of the chunk in our vector store. So that ID I'm going to store here in IDs, although we will not be needing this one later on, but just I'm saving here for the reference. So I write here vector store dot add document here. All right, one more thing I should tell you here, that if you want to know more about the vector store, you can just simply write here help and vector store. With this, you can see this whole document about this vector store. All right, so this is a complete document which you can just to walk through, and you can understand that what are the method which you can use. So in this you will be seeing somewhere add document method as well. Here you can see that add document, and then you can provide the list of the document that will get added to your vector store. All right, so you can use this help and any object name to get the complete help about that particular object or the method. So you have your vector store dot add document. Previously we had seen there in the documents you have to provide the list of the document. Currently I have a chunks, 321 chunks are there total. So I'm just going to run this. Now it is going to create the embedding for each of the chunk data, and those embeddings are going to be stored inside this vector store. And here ID is returned for the relevant chunk. If you print this IDs, you will be seeing here a list of all of these IDs. And if you get the the length of IDs, you should be getting here 321 IDs. Why 321? Because we had here 321 chunks here. Apart from that, let me just show you one more thing. While creating this FAISS database, I told you that this index to doc store ID will be used internally to map your IDs with the index. So you can get that here as well. Vector store dot index to doc store ID. If you just print this, you will be seeing all these IDs are actually mapped here with the individual index numbers here, 0, 1, 2, and so on. All right, so that is why I used that one. So I'm just gonna put it here. All right, perfect. All right, so I hope that till now these things are clear to you. Now you have your vector store here. Now what you have to do here, you can store your vector data inside your folder. Let's say tomorrow if you don't want to embed all these, all these PDF, then you can simply store your vector store once. So you can just write here your DB name. All right, so name of the DB which you are going to use to store your vector store. So let's say I write here health supplements. So this is our DB name, and now I'm going to store our vector store. So I can just simply say here vector store dot save local, and then I can say that here DB name. If you just run this, it is going to store here health supplement inside this index.phis and index.pkl. These two files are stored here. Later on, let's say if you are developing your question answer from the definite set of the PDF data, then in one code you can index your data, and thereafter in another code you can actually implement other part of your code, that is the retrieval and the generation process. All right, so this part you can use after embedding your document inside this vector database. All right, so once you store your data, here, thereafter you can also load this. Let's say I'm gonna say here new vector store, something like this. New vector store is equal to FAISS dot load local, and then you can just simply provide here the DB name from where we need to store this, and you have to also provide here the embeddings function. So Ollama embedding function we have to use here. Always do remember, if you are storing your database and thereafter you are loading it, you have to make sure that you provide the same kind of embedding function which you use to create your database. Otherwise you will not get the desired result. Thereafter I'm going to say here allow dangerous deserialization is equal to the true. In some cases if you have an embedding which is not supported properly, then making sure that this will make sure that it run properly. Thereafter, let's go ahead and run this. Now you have your new vector store. So this new vector store, you can just simply copy this whole thing from here and you can paste it here. You will be seeing here the length should be 321. All right, perfect. So this vector store and this vector store is now exactly the same. This whole thing, whatever you saw just here, this is the first one is store, another one is the load vector database. And here this one was the store. Let me just write here, store vector database. All right, perfect. Now what I'm going to do here, so we already have loaded and we have stored and loaded our vector database, but you do not need as of now this one. So I'm just going to comment this one so that later on if I run it again, so it should not create a problem. Otherwise what will happen here, health supplement is already created here. The next time if I try to create that, then this might throw the error. That is why I'm just going to comment this one. Otherwise, I just wanted to show you here that how you can store your vector database and then finally how you can load your vector database. Alright, so this was just for your learning purpose. Now we have reached here at this stage where I can show you that how you can retrieve your data from the vector store. So we have reached here to our retrieval and generation section. In this, first of all, I'll be showing you from one question how you can retrieve your the chunks, and thereafter I'll be showing you how you can pass this chunk of the data to your LLM model so that you can process for the final step. All right, so let's go ahead and get started with, wait a second, let me just put it here. Perfect. Let's go ahead and get started with the retrieval process. So I'm gonna write here retrieval. So in the retrieval process, you know that we have to have here some question. All right, so I'm going to provide here a question. So the first of all, I write here a question is equal to, let's say, I'm going to say that what is used to gain muscle mass. All right, so this is my health related question. And then this question will be used to extract the relevant chunk out of 321 chunk here. All right, let's go ahead and try to search through our vector store. So what I write here vector store dot search, and then I provide my query. So my query is here a question, and thereafter it says that what is search type, which search type we are going to use. It has here multiple search type. Currently I'm going to find out here just the similarity search type. All right, and thereafter I can, let's say I say here search type. This is our similarity search term. Thereafter, I can pass my search keywords. So you will see here there is another parameter, that is the keyword. So in this keywords, we can pass that how many output or how many relevant search data we want. Let's go ahead and just run this and then see what happens. By default, it is returning here 4 search result, and these are the chunk document. Here you will be seeing all of these things are there. All right, these contents are there, and seems like some relevant contents are returned here. Just to show this content properly, what I can say here, I can say that here docs is equal to something like this. Thereafter I can print all the relevant content here. So I can say that for doc in docs, and thereafter print doc dot page content. Thereafter I can print here to new line here, something like this. Let's go ahead and run this and then see what happens here. So this is our first answer, and there is the second one. It's not answer, it's actually the chunk. All right, so here we have a first chunk. My question was here, what is used to gain the muscle mass. Let's go ahead and see if it is matching properly, if there is anything there. So it says that yes, there is gain muscle mass. Some supplements are used here, creatine monohydrate, and maybe we should be seeing something related to muscles and strength here. I can see that as well, and some protein and creatine etc is shown there. And thereafter here we have some improving strength, etc., body shaping, which you can say that it is kind of related to the muscle mass, strength, and so on. Thereafter you have here some weight loss, etc. All right, so moreover, seems like whatever the result is returned here, that is quite relevant to our question. All right, so that is how you can retrieve the data from your vector store. Let's go ahead and come back to our architecture here. So in this architecture, what you will see here, whatever the question we have, those question will get embedded using Ollama embedding. And inside that, nomic embed text is being used. And once question embedding is generated, then through the cosine similarity, it is going to match our chunk, all right, inside this FAISS vector database. All right, and then whatever the relevant chunks are there, those chunk will be returned here. Later on, we can write our prompt and algorithm to pass the chunk along with this question to our LLM so that it can produce the final output or final response. I hope that till now it is pretty much clear to you. Now in next part, I mean right now, in the you can say that in next cell, I'm going to write here how you can convert your vector store as the retriever, so that every time you don't need to provide search type and so on. All right, so let's go ahead and convert this as the retriever. So what I write here, first of all, I write here retriever is equal to vector store as retriever. Inside this, I can pass our search algorithm. So there are many type of the search algorithm. Here we have vector store as retriever. We have many type. You can just simply click on here. You will be seeing search type. You have a similarity, MMR, all right, maximum marginal relevancy. Then you have here similarity score threshold and so on. All right, and in search keywords you have a k amount of documents you need to return, fetch k amount of document to pass to MRR algorithm, default is 20, and you have here lambda, all these things. So what I'm going to do here, I'm going to actually provide here, so in the search type I provide here MMR. I'm going to say here search type is going to be the MMR, and thereafter here we have our search keyword, right? Let me just put it here. Somehow that search keyword is not coming there, so I can just simply copy it from here, and then I can pass it as the dictionary here. So in search keyword we have a k. So the k is the total number of the document it need to return, and thereafter we have what are other parameter. We have a fetch k and we have also lambda mult here as well. Let's go ahead and write this fetch k here. So for fetch k, fetch underscore k, so it is going to fetch here 100 relevant document, and that will be passed to the MMR algorithm for the ranking. Thereafter here I'm gonna provide our lambda mult. So this lambda mult have a value in between. Let me just do it something like this so that you can see it properly. So this lambda mult has value in between 0 to 1. 0 means it is going to return result, a diverse result, and lambda mult 1 means it is going to return result only which is relevant to our query. So I'm going to provide here 1 so that I can get only those output which are quite relevant to our input or our question. So we have got here a retriever. Now from the next time you can just call here retriever dot invoke, and then you can just pass your question here. All right, now you can see here we have got here 3 output only. Why? Because k equal to 3 we have already provided here. Now what I'm going to do here, this whole thing I'm just going to copy it from there, and then I'm going to paste it here so that I can print that here as well. So I can say here docs is equal to like this, and then finally I run. So I can see here all the caffeine related things and etc, when fits popular choice etc, and thereafter here is the another one, and then you can just make it a little bit like this. Then you have creatine, monohydrates, and the protein and so many other stuff. So all those things you can see Here it says that the muscle building, etc. So whatever the question we have asked relevant to that, we are getting the answer here. One more thing I should tell you here, that if one type of the retriever is not working for you, I mean to say that one type of search is not working for you, you can try a different type of the search types as well. Here we have a similarity, we have MMR, and we have a similarity score threshold. Any of these you can try out and then see which type of search is working for you best or for your particular data types. This is one way to do here. Now, one more thing I should tell you here, that inside this .env, at the start of this lesson, we had stored our LangChain API key, LangChain project, endpoint, all those things we have stored. Now we should be able to see all these data to our LangChain, I mean to our LangChain Smith, right? So we come here and then we come here, and thereafter here inside the project, we should be able to see that chat my PDF data. So here inside chat my PDF data, we can see here these are the question which we had asked previously. The two times we asked question here. So what was the question? The question was here, what is used to increase the, I mean, gain the muscle mass, and these were the relevant output which was actually fetched, right? So this was the latest one where 3 document was fetched, and here we had the, the older one where 4 document was fetched here, right? Let me just see that here. Okay, seems like in this we are not able to see that. So in retriever, I mean in vector store.search, we are not able to see those, but through the retriever, whatever the document was fetched here, those document we can see here. So these are the output. In this output, now you can see your query is here, and here is the relevant document. You can just simply click on that, and then this whole document you can see here. And then it says that, okay, the total pages and etc. etc. So this is the metadata actually. So this is the metadata from where it is coming. It is coming from RAG, analysis of actual supplements. So that is the first one. The another one is coming from the high prevalence supplement intake, and third one is coming from the another source. Seems like in the same source. All right. So it's coming from same source, but the page number 6, this one is coming, and here this one is coming from page number 8, and the first one is coming from which page? The first one is coming from the page 0 out of total 15 pages. You see that how important this Lang Smith is here. So initially when we started this lesson, we had done setup for Lang Smith. Thereafter we did not use, but now we are using this. Now you can see that here how beneficial and how good this Lang Smith is here. All right, perfect. I hope that till now it is pretty much clear to you. Now what you can do here, you can ask here a multiple question, and you can just, avoid printing this one so that we can save here some space. All right, so now what I'm going to do here, I'm going to ask more questions here. All right, so I'm going to say here, more question means I have written some questions, the predefined questions, all those questions I'm just going to paste it here so that I can quickly test all those. So it says that what are the benefits of the BCAA supplements? I'm just going to run this inside this document that is stored, but the same thing we can see here at the Langsmith as well. Now I can see it here. So we have this one here. This is the latest one. What are the benefits of the BCCA? One more thing I should, do here. I should, remove this one. Otherwise, every time that will unnecessarily run in the background. That is why we saw there here this one, right? This one was running behind the scene. All right, let's go ahead and come back to our BCCA. So it says that here something related to BCAA. All right, that is the first. Here is the second one, and here is the third one. You might not get here everything related to BCAA, but moreover, whatever the output you will get here, those will be correlated to your search query. Let's go ahead and ask the another question. So the another question I'm going to say here, what are the benefits of the supplement? I'm just gonna run this here. So once you run it here, you should be able to see here, just click on the latest one. What are the benefits of the supplement? You should be able to see here all the supplements and their relevant benefit. You might not be able to see here all these things, the properly or in well formatted way. The reason is here we are not passing our chunk to LLM as of now. This is just retrieved chunk data. Later on, I'll be showing you how you can pass this chunk data along with this question to your LLM so that it can process your final response. All right, that is why you are seeing all these documents only, right? So these are the documents only. Currently we do not have we do not have attached these document with the LLM. All right, so I hope that this is pretty much clear to you by now. Let's go ahead and see here this one, what is used to reduce the weight. I'm just going to run this and then I'll just come here. Now I can see it here, the latest one, and it says that somewhere here, what is used to reduce the weight. Now whatever the output you will see here, that must be related to some weight. Now you can see here weight loss supplement is there, and similarly you will see here some weight loss, etc., dietary supplement and the weight loss, all of these things you will be seeing here. All right, so now one thing is sure here, whatever the output or whatever the data chunk we are getting here, that is quite relevant to our question. Now till this part we are done here. Now we have also done document ingestion previously through the PDFs to the FAISS vector database. Now we have also reached here at this stage. Now what is left here? Only thing is left here, doing this RAG. All right, RAG with our LLM, where we'll be using Llama 3.2. All right, so we'll be passing our chunk data, all the chunk data which is retrieved to our LLM along with this question, and then we will be getting here output. All right, I hope that till now it is pretty much clear to you. So now what I'm going to do here, I'm just going to get the screenshot of this so that I can paste it there for the reference. All right, so in this you can get the reference. Here I'm going to say that, in fact, instead of there, here at the retrieval, I can put it here at the retrieval itself, right? So this is the whole process. Now we are left with this process. So what I can do here, I can come here and then I can write here in the markdown, this is going to be the RAG with Llama 3.2 on Ollama. Perfect. So we'll start this with importing our hub from the LangChain. So I write here from LangChain import hub. This markdown need to be here Python code. Let me just add here some additional code cell as well. So from the LangChain import hub, thereafter we need to import here output parser. So from LangChain dot output parser import str output parser. So that we can get the string output here. All right, apart from that, we are going to import here runnable pass-through as well. So from LangChain dot runnables import from LangChain, this should be actually LangChain underscore core output parser, and thereafter here LangChain core dot runnables import runnable pass-through. Thereafter from LangChain core dot prompts import chat prompt template. I'll tell you why I'm importing all of these. Let me just import all these and then I'll let you know. From LangChain Ollama import chat Ollama. All right, let's go ahead and see why we have imported all these. So the first of all, you see here we have imported hub from the LangChain. So why we imported hub? From the hub we are going to pull out some RAG related prompts. Thereafter we have here output parser. So we are going to get here str output parser. So using this str output parser, we will be getting this final output as a string data. Thereafter we have here runnable pass-through. So why runnable pass-through? We need runnable pass-through so that we can pass this question directly to our LLM and we can pass our context directly from here to our LLM. So for this question, we will be using their runnable pass-through. Thereafter, we have here a chat prompt template. So this chat prompt template we need for our prompt data so that we can pass our prompt inside this chat prompt template, and then we can pass our context and the question. So the context is the chunk of the data. Thereafter, we have here a chat Ollama. So this chat Ollama is like here you can see here. So you have Ollama, and then through the chat Ollama, your LangChain can connect this Llama 3.2, which is running here at the Ollama server. So we will be using their chat prompt template and the chat Ollama. So the chat Ollama is like making a connection between your Llama 3.2 and your LangChain framework. All right. Perfect. Let's go ahead and import all these. So I have imported all of these. Let's go ahead and get our model here. So I write here model is equal to chat Ollama, and here I'm going to provide my model name. So which model I'm going to use here? Llama 3.2 1 billion model. So this is our model which we are going to use, and thereafter we need to provide here a base URL. Do you remember the base URL previously which we had used? So we used here http, all right, // localhost 11434. So this is our base URL which we had used here. Now we have got our model. You can just simply call your model, just typing hi. So you will see here that your model is working perfectly here. So it says that, hi, how can I assist you? All right. So seems like your model is working perfectly here. Llama 3.2 1 billion model is doing great here. All right. Now we have got our model. Let's go ahead and fetch a prompt from our hub. Now the question is, where is LangChain hub? You need to come here at the Langsmith. Thereafter, you will be seeing here LangChain hub at the Langsmith. Then you will get all the relevant, the prompt template here. Let's say we want prompt template related to the RAG. You can just search here RAG, and then you can find out all the relevant RAG related prompts here. All right, let's say you want to see this one here, RAG prompt. So this is relevant RAG prompt here. All right, you can see here some sample questions, sample code here as well. Along with that, here later on you will be seeing chat prompt template. So this is your chat prompt template, some relevant chat prompt template. Okay, if you don't like that one, you can also see other. So there are so many actually, right? So you can just take any of these from here. So you have here, this is forked from the RLM RAG prompt. So this is the original one, RLM RAG prompt. This is your, prompt template here. So this is something which we can use here. So I'm just going to copy this from here, and then I'll be pasting it here so that I can actually pull out this prompt. Now I have downloaded that here. You can see that prompt here. So inside this prompt, you will be able to see your prompt here. It should be here. Yes, here. So it's a template here, and you are assistant for the question answering task, use the following pieces, retrieved context, etc. So basically you can see this whole information here. You are assistant for the question answering task, use the following pieces of the retrieved context and answer the questions, etc., etc. Then here will be the question, and then there will be the context. So the context is those, the chunk of the document, and then final it will return the answer here. All right, if you want to modify this, you can also modify this as well. So we have already got here prompt. If you don't like to use this particular prompt, then what you can do here, you can just simply copy this whole thing, whatever you have here, then you can paste that here. So you can say that, this is your custom prompt, let's say. In case if you don't want to use this particular prompt, only then use this one, what I'm going to write here. So this is prompt which is there. Now let's say you want to do some modification in this prompt. All right. Let's say I want to say my LLM that I always answer in bullet point. All right. So currently there is nothing related to bullet point, although it says that answer maximum in 3 sentences. So it will keep the answer short and brief. but it's not guarantee that it will give you answer in the bullet point. So I'm going to write here, if possible, answer in bullet point, and then I'm going to say that here, make sure your answer is relevant to the question and it is answered from the context only, right? Perfect. So it will make sure that whatever the answer is written here, that is grounded with the context. All right, so this is your prompt data. Now if you print your prompt, you will see here a different prompt, right? The previously you were seeing some chat prompt template, etc., etc., but now you cannot see that. So to get that, what you can do here, you can say that prompt is equal to chat prompt template, and then you can say that from template, and then you can pass this prompt, and thereafter if you print this prompt, you should be able to see it in a similar fashion, chat prompt template, what we had got here. All right, so you might be asking that why we use this one. I just wanted to show you that if you don't want to write your prompt by yourself, then you can just simply use this technique to pull your prompt from the LangChain hub. All right, so we have got our custom prompt here. Let's go ahead and create our RAG chain here. So in the RAG chain, we need to come back here and just to see our architecture overall here. So this is our data, and this is going to work as a context, and here this is our input question. All right, so there is the data, and here is our input, the question, and then finally there is the LLM. So this is all we need here. All right, let's go ahead and first of all combine all the chunk data which we have here into a single text data so that we can pass this whole document as a single context here. So what I write here, first of all, I'm going to write here diff format underscore docs. I'm going to pass all the document inside this, and then finally I can just simply return it here by joining with multiple, couple of new lines, and then I say that here doc dot page content for doc in docs. So what it is going to do here, it is going to iterate over all the document, and thereafter it is going to combine the page content of all document with the two new lines. You can just call this format docs, and inside that you can just simply pass your docs, and then you would be able to see that. You can just use here a print. After this print, you should be able to see here. So this is our first one, here is our second one, and thereafter you will also see there our third one. All right, so this is our context which we had actually got previously. All right, I'm just going to comment this one so that I can save some space. So format doc is now ready. Now we need to prepare our RAG chain. So I write here RAG chain is equal to, first of all, what we have to do here, we have to provide here, a runnable pass through, and that is going to be like a dictionary here. So we need to provide here a context. So this is like a dictionary, right? So this dictionary is going to be passed to our prompt. So first of all, I pass here this context. So what is that context? This is going to be this particular thing, right? Format doc and docs here. So I write it something like this. So we have here our, the context, and then inside this context, we have to pass your format doc. Now the question is here from where this document is going to come. So for that purpose, what we have to do here, we have to call our retriever first of all. All right. So in this way, what will happen, whenever we pass a question, that will get passed to the retriever. So through the retriever dot invoke, what we see here, through the retriever dot invoke and the question, it will return the set of the document, and then that set of the document will be passed automatically to your format doc, and then it will return this context. All right, so this whole string, a single string actually, and that string will be stored here inside the context dictionary. Thereafter, what you have to do here, then we have to pass our question here separately. So currently we are not passing our question directly here. We will be just passing here empty runnable pass through, Basically, it is something like a pass-through where we are not defining anything in our chain, but we are just putting there a placeholder that we will pass our question later on when we will be calling our LLM. So I put here question, then the runnable pass-through. Thereafter, once this part is done, then I need to I need to prepare my prompt here. All right, so what happened here? Now we have our prompt. All right, so here at prompt, what happened here? You know, so in this prompt, this is our chat template. So we have our context and there is the question, and through this runnable pass through, that question will automatically get passed to the question. And here is the prompt. So this final prompt will be, returned here, and then this prompt will be passed to our model, and that model is here. All right, so this chat Ollama, this will be passed to our chat Ollama, and once output is produced by the model, then that output will be actually parsed by output parser, and that is the string output parser. So this whole thing is done here. Now I'm just going to run it here, and thereafter I can just simply copy all our question from here, and then I can come here, scroll it down, and then I can just simply call our RAG chain here. So I can just simply say that here output is equal to RAG chain dot invoke, and here I can just simply pass my question. So this is going to be the first question here. All right, let me just copy the other question where I had asked that how to gain the muscle mass, this question as well, so that I can get the answer for that as well. I put it there. First question is going to be what is used to gain the muscle mass, that is going to be passed inside this RAG chain, and then through the retriever it is going to retrieve the chunk of the data, and then through the format document it is going to combine all the chunk data together as a single string, and then the question is also going to be passed directly to the question, and then the prompt will be prepared and that is going to be passed to your model, and then finally it is going to produce the final output. Let's go ahead and run this and then see what happens. So with this output I can see my output here, so I can just print this output. This is our output. So protein source, caffeine and creatine monohydrate, these are used to actually gain the muscle mass. All right, seems like the answer is not so descriptive. The problem could be here that it says that use 3 sentences. All right, so this part I can just remove that so that it should not restrict itself into just 3 sentences. All right, then I say that here answer in the bullet point, etc. I'm just going to prepare our prompt again. Thereafter I can just do that one. In fact, instead of doing that, I can just print it here. All right, now you can see here that 3 sentence restriction is removed. Now I can see here in the detail, right? So creatine monohydrate is well known supplement that helps with the gaining muscle mass, etc. So all those things are coming from the document. Now the question is, how would you know that? For that purpose, you can come here at the Langsmith, then here at the project, chat my PDF, that was our project. And in that project, this is our latest runnable sequence. You can click on there. You can see here the question, what is used to gain the muscle mass? This is our final output. So this was the final output which was produced. Now what was passed here? So you can see that here vector store retriever. In vector store retriever, you will see here these were the input, the chunk data which were passed there to the LLM, so that LLM can actually process this. Through this architecture, you can understand here all the chunk were passed to your LLM along with this question, and then finally LLM look into these data and then it answered based on only these context or provided context here. So through this one you can see, and then through the format document, you got here a final document, a single string data that was combined together. And then through this chat Ollama, we passed our question, and then we passed our format document final output to our LLM. And then finally, we have our prompt here. So it says that you are assistant for question answering time. Do you remember that? This is exactly the same prompt what we had prepared previously. All right, so this is our prompt, and then the question comes here, what is used to gain the muscle mass? So through the runnable pass through, our question is passed here to the question, and then here is the context. So this was our context here. So all of these context, whatever you see there, these contexts were used there, and then finally there is the answer here. All right, and then it write here the answer based on the context whatever we provide. Now through this architecture, it should be clear to you by now that how this overall RAG process is working here. Now I come back here. Thereafter, I'm going to use here something like this. What is used to reduce the weight? And then it says that here are answer. Okay. So weight loss supplement do not help people lose weight due to the lack of evidence. So it says that weight loss is not something like, some magic. There is no conclusive evidence, etc. And if there is any supplement somewhere, I mean, it should say there somewhere, yeah, unauthorized buyers or the sellers are there. So mostly sometimes it is illegal if there is something which is related to weight loss, because really there is nothing like weight loss medicine as of now in the market. All right. Other than having a good diet and doing good amount of the exercise, it's really difficult to lose the weight. Thereafter, here we have what are the side effects of the supplement. So it says that okay, these are the side effects. All right, so weight loss and bodybuilding supplements, they are associated with the quite severe effects. And then here it says that you know all of these are the side effects. All right, thereafter let's go ahead and see here what are the benefits of the supplements. It should be telling us about the benefits here. All right, so here it says that these are the benefits. If you have these supplements, then these supplements can provide these kind of the benefit to you. Thereafter, we have here what are the benefit of BCAA supplements. It says that support muscle growth and strength, reduce post-workout soreness, and then improve overall muscle functions and the recovery. And it also elevate delayed onset muscle soreness. All right. So you see that how good it is actually, right? You can also check here. Let's say you get some question, out of this world. Let's say I'm gonna say that what is used to increase mass of the earth? Let's say this is irrelevant to our question. I mean, irrelevant to our context, right? So here you see there, it says that there is no mention of anything being used to increase the mass of earth. All right. So it clearly says that it could not get, enough information about this particular question. Now, this proves that whatever the answer you were getting previously, those answers were coming from the context, provided the context. Now I, provided here some question and the context was not good there, then obviously you will be getting answer something like this, where it says that, it could not find out in the provided context or provided text data. All right, so I hope that this overall, you know, overall tutorial was helpful to you. I have tried my best to give you the best knowledge here and in very simple and stepwise step manner, so that you can learn, you can make your own, the RAG, the algorithm using LangChain and the Ollama. I hope that this was helpful to you. Please do like this video and subscribe this channel. And if possible, please do share this on LinkedIn and other social media. Thank you so much. Bye bye. Take care.